Now I want us to take some time to talk about square units. And what a square unit is it's how we measure area. You see at the top of this image here, we see find the area of these figures. And so we're used to measuring length. Length can be measured in centimeters and meters and inches and feet. But area is actually talking about an object that has two dimensions. It has length and width. And we want to know how much area it takes up. And we don't measure that just in centimeters or inches. We measure it in square centimeters or square inches. And so you notice I have a grid here, and the grid is actually divided into squares, and all the squares are 1 centimeter long and 1 centimeter wide. So each of these squares we're going to call 1 square centimeter. And all we have to be able to do is find out how many of those squares an object makes up to find its area. So if we want to find the area of A, one way we could do it is we could simply count the squares. And so I see that A has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares. But then I also see that there's a half, a half, a half, and a half. And so it's actually, those halves add up to be 2 wholes. So it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, plus 2. A is 16 square centimeters. And you're usually going to actually see me write it with using an exponent. Most of the time people write square centimeters as centimeters with a little superscripted 2. When we get to area of a square, you're going to understand why we can use an exponent of 2 to mean square units. But if you put 16 centimeters on this problem, it's actually not right. It's actually 16 square centimeters. And area always has to be written in square units. Okay, so let's take a look at B. B is a little bit more difficult because we notice that we do have some fractional units. Let me show you over here in red. We have a triangle right here and a triangle right here. But what we notice is those don't cut units exactly in half. Let me try to make this triangle a little bit better. I'm not real happy with that one. But we actually notice that it does cut them in pieces, but it doesn't cut them exactly in halves. And so we're going to have to talk about another way to find out how many units they are. And plus we'll talk about a little shortcut, because if I take the triangles off, what B is a rectangle. And we notice the rectangle has 1, 2, 3, 4, 5, 6 in a column, and it's got 2 columns. And so we actually know that the blue rectangle has 12 square centimeters in it. And you'll notice that really that's the same thing as 2 times 6. You've worked with rectangular arrays, and you know that if you have 2 rows of 6, you have 12 square units. And we're going to talk later on about length times width, being how to find the area of a rectangle. But now the question is going to be, what do I do with these fractional units? Okay, and so one of the things I noticed that we're going to do is I'm actually going to say, well, that triangle is exactly half of a rectangle, and the rectangle has 2 squares in it, and so does this rectangle down here at the bottom. It also has 2 squares. Both of my green rectangles have 2 squares. And so if we look at these red triangles right here, let me shade them so we know exactly what I'm talking about. This red triangle and this red triangle each take up exactly half. And so if the rectangle has 2 units, then each of the red triangles must be half of 2, which is 1. And so we already have 12 square units, and then we just have 1 and 1 again. And so we know that B has an area of 14 square centimeters. If we see a shape that's irregular, we should chop it up into rectangles and into triangles and squares, and we can more easily find the exact area. So with that being done, why don't you put it on pause and see if you can put what you think the areas of C, D, and E are, and then you can hit play again, and we'll go ahead and solve those together. Okay, I hope you've had a chance to do that. C is a little more complicated than the ones we've had before, so let's do this. Let's go ahead and identify our fractional pieces, and we'll go ahead and kind of cut those off. And so I notice right here I have a blue triangle. I'm going to do all these in blue. Here's another one, and then here's another. and these are all fractional pieces. Well, I notice with what's left that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 14 square centimeters that aren't fractions. And so then what I need to do is figure out these blue parts that left, what they do. Well, I recognize that this rectangle has 2 units, and this rectangle has 2 units, and both of those, the triangles that we need, are half of that. So I have 1 square centimeter in this triangle and another square centimeter in this triangle. Then down at the bottom, I can actually divide that in half, and I notice that this has 2 units, and so does this. So each of these smaller ones must also be 1 square centimeter. And so what I actually have is 14 plus 1 plus 1 plus 1 plus 1. And so I have that C equals 18 square centimeters. D is actually just a bit easier because D only has these 2 triangles, and then we're going to have a rectangle. And so here's what I have with D. 2 triangles, and then in the middle I have a rectangle. And actually, when I count it, the rectangle is actually a square. It's 4 rows of 4. We know we can do that by just doing 4 times 4, and so we know that this square is 16 square centimeters. So now we can go over here to our triangles, and notice that the triangles are still half of a rectangle. We're going to learn in a future video that every triangle is half of a rectangle. These rectangles have 4 units, and so if the triangle is half of that, half of 4 is 2. So this triangle is 2 square centimeters, and this triangle is 2 square centimeters. And so if I do 16 plus 4 plus, 16 plus 2 plus 2, which is the same as 16 plus 4, then I get that D is 20 square centimeters. Finally, E also has some fraction units, and you got to be careful because if you try, what makes E confusing is some people will try to take all the whole units and add them up, but actually the easiest way to do E is to chop off this triangle right here. And the reason is because that leaves a rectangle, and rectangles are the easiest shape to find the area of. This has 3 rows of 4. You could count them, but we know that we could do 3 times 4, and we get that it's 12 square centimeters. And then we can come over here, and we said that every triangle is half of a rectangle, and so I could actually say, well, it's half of this rectangle. Notice this rectangle also is 12 square centimeters. It's 3 by 4, and so half of it's in the triangle, so that must be 6. And if I add 12 and 6, I get that figure E has an area of 18 square centimeters. And now I can answer my question at the bottom, which figure has the greatest area? And I see that D is 20 square centimeters, which has the smallest area, and I notice that B is only 14 square centimeters. And then see which 2 figures have the same area. C and E both have an area of 18 square centimeters. And so that's what area is. It's just the number of squares that an object takes up, and sometimes those may be cut in half, but we can usually find rectangles and squares and triangles to be able to figure out even what fractions those are. And so that's how square units and area work.